Good morning. This topic is selection chart, the design analysis of algorithm. So this selection chart comes under brute force technique. Brute force technique is nothing but a straightforward approach for solving a problem. Usually, it is directly based on the problem definitions and the concepts involved. That is brute force technique. And we also some advantages of brute force techniques, that is wide applicability, its simplicity, its reasonable algorithms for some important problems like matrix multiplication, sorting, searching, string matching. So under the brute force technique, today's topic is selection chart. So selection chart is nothing but it searches for the biggest value as it makes a pass, and after finishing the pass it is in the best possible replicas. Start selecting by scanning the entire list to find its smallest element and exchange it with the first element in the shorter list. Then scan the list from second element, find the smallest among last n minus 1 elements and exchange it with the second element. That's what given here in the selection chart. First of all, we have to set the initial element as minimum. The first element is considered as minimum element. Now we will compare the minimum with second element. That is first element and second element. Now first element is minimum element. That minimum element should be compared with second element. For example, in array we have 5 elements. That is 1 of 2, 3 to 5. So first we have to compare this 1 and 2. This 1 should be selected as minimum element. So we fixed as minimum element. Then if the second element turns out to be smaller than minimum, that is here the element is if the first element is 5 and second element is 3, first we are setting this 5 as minimum. Now we are going to compare 5 with 3. If this 3 is minimum, we should swap this. This is only rule. So now we compare the minimum and second element. If the second element turns out to be smaller than minimum, yes, here 3 is smaller than 5 minimum. So we'll swap. Followed by assigning to minimum to third element. Same process will be done until n number of elements. So else, if the second element is greater than minimum, which is our first element, then we'll do nothing. We have to move on to third element and then compare with minimum. Then first and third element should be compared. For example, 5, 8 and 7. While comparing 1 and 2, it is the minimum element. So no need to worry about 5 and 8. Now we have to compare with 5 and 7. Here 5 and 7, no need to worry. Here next element is 3. Then we have to compare 5 and 3. Yes, 3 is smaller. So we set this as minimum element and we have to proceed further. This is the process of selection chart. So we'll repeat the process until we reach the last element. After the completion of each iteration, we will notice that our minimum has reached the start of the unsorted list. That is, first element should be the minimum element throughout the list. So for each iteration, we will start indexing from the first element of the unsorted list. We will repeat the steps 1 to 4 until we reach the odd element in a correct position. This is the process of selection chart. So this is the algorithm. First, the input is of array size is 0 to n minus 1 elements, and we have to sort it in ascending or descending order. This is our output. For this, we are doing swapping. We are comparing two elements, so we need two arrays I and j loop I am taking. For I is equal to 0 to n minus 1 last element of the process, and first element should be considered as minimum element, that is I is equal to minimum, setting the first element as minimum. Then j loop is for j is equal to I plus 1 to n minus 1. For example, 0th interpretation, first and second and third. We have an element 5, 3, 8. The algorithm is this element is taken as minimum, that is I is equal to 0 is minimum. So in the expression I is 0 as minimum. Then we have to compare with 1, I plus 1. Here, see, j loop is I plus 1, that is 0 plus 1, 1. You have to compare 5 and 1. This is j loop, I plus 1 to n minus 1. Then, p of j is less than minimum. This is minimum. minimum and I are in same pointer. This is the I pointer and this is the minimum pointer. The second one, this 3 is considered as J pointer. So now I pointer, minimum pointer at same place and J pointer is at index position 1. Now we are comparing the two elements. If A of J is less than A of minimum, then we have to change the minimum value as J, or else no need to do. Then we have to swap the A of J and A of minimum value. Now we have A of J and A of minimum swap. So this is the process of share. Here I have given an example, simple example. Here we have 5 elements starting from index position 0 to 4. 7, 4, 3, 6 and 5. So first time we are going to compare 7 with 4. First I is considered as minimum element. Now this is minimum element, this is I pointer and 4 is J pointer. First condition we are comparing minimum with second element. The condition is satisfied? No. So now we have to fix this 4 as minimum element. See 4 as minimum element. Then we have to compare 4 with next element 3. Now we have to check 4 and 3. Yes, the condition fails. So we have to swap 4 and 3. Now 3 as minimum element. Swap with 3 and 6. Sorry, check with 3 and 6. Is this condition correct? No. 3 is smaller than 6. So no problem. So we have to move 5. So 3 with 5. We have to compare 3 and 5. Now also condition is correct. If the condition is correct now, this is minimum. At last, we have to swap this minimum element with this 7th position. That is the 0th index position 7. Now 3 and 7 get swapped. At last, at the end of first iteration, this 3 is considered minimum element. So this minimum element is replaced with this 0th position index 3. Now this 3 is fixed. We should not disturb this. At the end of selection chart first iteration, 3 get fixed. So at the end of each and every iteration, one element get fixed, that the smallest element will get fixed. So now 3 get fixed. So second iteration, we have to take 4 as minimum element, compare this 4 with next element 7. Now condition is correct, no problem. Then we have to check 4 with 6. Now also condition is correct, no problem. Now 4 with 5, condition is correct, no problem. So this minimum element we should not replace anywhere because the correct position is correct. So 4. So now 4 got fixed at the end of second item. So next, the third iteration, we have to compare 7 with 6. Here itself the condition gets failed. So we have to swap 6 and 7. Now 6 is set as minimum. 6 with 5. Now condition gets failed. So we should replace 5 and 6. Now 5. So now 5 and this 7 should get replaced. That is swapped. So at the end of third iteration, 3, 4, 5, 6, 7. So next we are incremented to I as 3, index value 3, 3 with next value 4, 6 and 7 condition is correct. So no need of any more swapping is required. So at the end, the list is in ascending order. So this is a general complexity analysis. We know the sum of n number is n into n minus 1 by 2. So we take as order of n square as complexity analysis for selection chart. Here, the space complexity is, in case of space complexity, we are using swapping technique here. For swapping, we need a temporary variable. So for that temporary variable, we need one extra space memory. So that extra one space memory require order of one time complexity. So space complexity. So time complexity is order of n square and space complexity is order of 1 here. So this case complexity is order of n square, average case complexity is order of n square, and worst case is also order of n square. So in case of selection chart, the complexity analysis is order of n square. For here, the basic operation count is summation of is equal to 0 to n minus 2. And by using for loop, we have two loops. So summation of I equal to 0 to n minus 2 and j is equal to, sorry, not 0. J starts from next element. No, next element is I plus 1 to before element is n minus 1. So for each step we need 1. So 1. So this is a general basic operation count formula, that is summation of I equal to 0 to n minus 2 and summation of j1 is equal to I plus 1 to n minus 1 1. So while completing this, we'll get the answer as summation of I equal to 0 to minus 2 minus 1 minus I. So after completing this, we'll get the answer as n into n minus 1 by 2. That is sum of n numbers formula. N into n minus 1 by 2 will take as n square as complexity analysis. So, complexity analysis for this sorting algorithm is order of n square, and space complexity is order of 1 because of one space required for swapping. That's all about sorting.